And it's important that we just briefly, this will only take us 20 minutes or so, just so we get a common understanding of what each of these technologies are, because you could be, going back to work on Friday or Monday or researching this area, and I think it's important to know what they are, what's the basic premise of how each technology works really. So we'll start with the CHP. Please, again, if anyone has been involved in the creation or the installation or has a working knowledge of these systems, please just chip in and give your thoughts about whether you think it's a good system or a poor system and what's working and what's not. So this is basically a combined heat and power plant. It's basically a power station that generates electricity and heat from gas. So it's not a renewable source because it comes from the national grid. So it's deemed to be a low carbon source. Has anyone got an experience with a CHP? No? Okay. As we mentioned before, it's widely used, widely accepted, can be a fantastic system. And there's a number of different projects all over the UK, all over Europe, where they are proven to work and continue to work. So it's definitely something, but on a larger scale.
More effective if they can generate heat and self-heat.
Yes. Yeah, they can. And it's all to do with the conversion and the burning of gas. It's much more efficient to use a CHP plant. You can also have micro CHP, which is in the bottom right there of the screen. And we can also have district or community CHP as well. So the district side of things is a combined heat and power plant that serves to facilitate a whole community or a district. And again, online there's lots of examples of how these work. Now the finances around that and the structure around how that works is quite complex. So you need to get sort of buy-in from the whole community, and it's not that simple. Does anyone have any experience of that?
I did for a village for biomass, which is the same issue, but it took 2 people 3 months to get 85% people to sign up. Massively time-consuming in one village.
Yeah. So it works, but you have to get buy-in from everyone involved, and it's not easy at all. The micro CHP is okay. It's more expensive than a normal boiler, so why would you use it? And it's can be useful, but not that common. I mean, will we see a change in that as time goes on? Probably see more of this coming through. But it's a good overall, it's a good solution. We add a cooling element to this. So the CHP plant, as well as creating heat and power, can also cool, which we've just heard. So it's called a tri-generation facility, and it's that tri-generation facility is used in the example I gave this morning in Sydney for One Central Park. So they use a tri-generation, and they also use it to cool a facility as well. So another good example there. And I think the key is for us today is to not really look at these renewable options as being separate systems. As we sit here today, we have CHP, we have tri-generation. In 6 months' time, there could be another system. And you've got to keep an open mind to all of this, is that there will be new emerging technologies all the time coming through. St Bart's Hospital in London uses a tri-generation facility as well. And as you can imagine, fitting that sort of system into an operational hospital is a massive operational challenge. If you're having an operation and you're lying on an operating theatre, the last thing you want is the power to go off in that building. You don't care about the carbon emissions when you're having an operation. You care about power being on. So fitting the tri-generation facility into an existing facility in the operation of a hospital was a major undertaking, but they've done it. Another technology that you should be aware of is what they call fuel cells, and you've seen fuel cells, which is basically looking at hydrogen to generate heat and electricity again. There's all different types of fuel cells. There's solid oxide, there's proton exchange membrane fuel cells, there's ones where they remain fixed in cars. You have a hydrogen fuel cell car, or a hydrogen fuel cell bus, or you can have other systems which you can use in big facilities. Just as a anecdote really, how much do you think it costs for a double-decker bus? You'll see where I'm going with this in a minute. How much do you think a double-decker bus costs? Yes, it's about 150, so like that one outside, like 150,000, 200,000. So the hydrogen bus in London, how much did that cost? 1.2, yeah. So every passenger has to pay. But so the reason why that works is it's a demonstrator, so it's funded by European money. It's there to to engender change and to try and persuade people to go down this route. But you've also got the problem with fuel cells of hydrogen storage, because hydrogen needs to be leaked to the atmosphere. It's explosive. So it's an option, but
it's not the best option.
It depends on your opinion. For Woking Park they use a fuel cell. They use a fuel cell CHP. So this is what I mentioned earlier, is that you can combine systems. So you have a combined heat and power plant with a fuel cell, so it reforms gas into hydrogen. So you may think, well, do you know what? It's a poor option, but it's being used, and it's being used to create electricity and heat in that particular facility.
Is it more efficient to heat using hydrogen rather than natural gas? Because I mean that
one of the problems.
Change.
One of the problems. It's a good question to ask. When you look at case studies on renewable energy online, every single project you look at is commercially sensitive. It is extremely difficult, if not impossible, to get any real information about conversion rates, about numbers, everything else. So the answer is, I don't know. On a purely mathematical approach or an engineering approach, the answer is yes. But in practical application and in practice, I do not know. And you will struggle if searching online for anything like this. You're not going to find the answer, because I've tried. And unless you're involved with the project, everything's so commercially sensitive. It becomes a trade secret, unfortunately. So it's a bit of a cop-out, but that's the way it is, I'm afraid. Chartered Institute of Building Services engineers, their headquarters, they use fuel cell micro CHP as well. So there are examples out there. I tried phoning them to find out more information about. No, you try contacting these places to find out more. It's very, very. Has anyone found the same or? Yeah, it's just.
They're very secretive.
So it's secretive, but it's secretive for a reason. Why do you think that is? Because I think most of the projects aren't commercially viable. They're running them, but I think they're losing money, and I think most of them are working well, some aren't. For example, I did some work with through a third party for a famous fast food chain, which I can't mention, which begins with M. And they had an idea. McDonald's, had an idea 20 years ago. It was when I was involved through a third party to use the fat and the waste to power the trucks to do all the deliveries. So they've done it. So they have biogas fueled delivery trucks for McDonald's. That fuel that literally. So when they go to the next store, they'll get the product, they'll refine it, they'll put it into the engine, they go on and do all of the deliveries. It's not commercially viable. It's not. They're losing money. No, they're losing money by doing it. But they've gone down the road so far and they've advertised it and branded it and so on that they can't go back. So for that part of the fleet, it's losing quite a bit of money.
And they have kicked out the guilt.
For now. Um,
For now, yeah.
energy from waste plants, just to be clear on what it is a simple little 5-stage there. So waste products fed into a boiler, and that waste becomes the fuel to generate steam. And the steam's recovered and it goes through various processes. So it's just a way to divert energy, waste products from a landfill and burn the waste and create power from it.
It's very expensive.
It's hugely expensive, and an example of that is Suffolk have an energy from waste plant. They take huge sums of waste, 380,000 tonnes of waste goes in there, and that's enough for 25 megawatts of electricity. So it's a huge, it's 25,000 homes they can provide power for.
Burn plastics as well, is it just like?
It has to be, as I understand the process, it has to be organic material, because when you burn organic material, it releases methane, CH4, and the methane is what you can use for power generation.
What do they use to burn the material? If I may ask, I'm not very well acquainted with it.
So what do they use? What do you mean by what do they use?
I think they use hydrocarbons to burn.
They do, yeah. Which is why it's a low carbon solution. It's not a renewable solution. So they're using fossil fuels to burn. Yeah.
An incineration-based process rather than
Yeah.
gasification.
Yeah. So it's not, it's not ideal, but I mean the other option is with their waste, of course, is to send it to landfill, and then there's a landfill tax placed on it. So if you have organic waste, it goes into an organic landfill, which is called MSW, Municipal Solid Waste. You pay a tax on it, and then it goes into a landfill, and that creates gas, and that gas needs to be treated and vented and so on. It's a big problem.
I think it's a bit unfair to put, on the one hand, wind and solar, and on the other hand, all the other solutions into under one label of renewable energy. Because
Fair point.
sun and wind are there. I mean,
Yeah.
we've got the biggest source of energy, which is the sun, and we're not using it. And then we go and say, waste is a renewable energy.
Well, no, waste is a low carbon solution, whereas
But it's under
the other ones are renewable.
energy.
Well, for me it isn't. So the renewable ones are listed there. So all of these renewables. So my energy from waste is in low carbon. For me, it's not a renewable solution.